All right. I'm going to work through these 14 problems here. We'll start off with number one. If I could click on it. There we go. Okay. So it says a patient weighing 10 kilograms is ordered acetaminophen 15 milligrams per kilogram per dose. The medication is supplied as 160 milligrams per 5 ml. What is the correct dose to be administered? So the first thing they want to know is what milligrams and then how many milliliters. So to get to the milligram part, we're just going to take the patient's weight, 10 kilograms, multiply by the 15 milligrams per kilogram. So that's per dose, but I'm not going to include that. I don't think that's necessary to add in there. And then we're going to get 150 milligrams. So 150 milligrams. And then we need to take the 150 milligrams and convert it to ml. So I have 150 milligrams times, I want to get rid of milligrams per ml. So 160 and 5. This one I will use my calculator for. So I'm going to take 150 times 5 equals 750 divided by 160. And I'm going to get 4.6875. We're going to round that to the nearest tenth, but I'm going to write out 4.6875. And we're going to round that to 4.7 milliliters. I'm rounding to the nearest tenth just because that is um, how I've been taught to round ML answers. So if that's you always want to double check with your instructor if they want you to follow different rounding rules. All right, for number two, um, the physician orders morphine sulfate oral solution, 30 milligrams by mouth, PO by mouth, every 4 hours as needed for pain. The pharmacy supplies morphine sulfate, 20 milligrams per 5 ml. How many ml should the nurse administer? So this one is just taking the order, which is 30, and then converting it to milliliters via the available. So if you're somebody who's learned order over available or desired over have, that would be set up like this. My order is 30 milligrams, my available is 20 milligrams, and then my quantity is 5. And you could have done this same setup with question one when we went here. I'm showing you two different ways just so you know that there are a couple of different ways that you can set up your problems. It all ends up being the same. We're still multiplying 30 times 5 divided by 20, whether I set it up the way I did in number one or I set it up this way, the way I did in number two. So 30 times 5 is 150 divided by 20, and I'm going to get 7.5 milliliters. Okay, number three, the hypoglycemic patient is ordered half or zero point 0.5 ampule of 50% dextrose. The pharmacy supplies 25 milliliter ampules of 50% dextrose. How many ml should the nurse administer? So this one can get like tricky because there's a lot of numbers here. So the 50% dextrose just tells you what what it is. Like you don't need to do anything with that 50. So just you could just kind of ignore that number. Just know that it's half dextrose. It's the half water. What you do need to know and realize is that, and I'll show you two different things. So it says the order is zero point 0.5 ampule, and then it says each ampule is 25 milliliters. So you're just going to give half of the ampule. So the answer would just be 12.5 without doing any kind of math setup. But if I were to set this up, this is what I would do. I would take my order. So I'm just going to write zero point 0.5 for the ampule. I'm just going to write A over my available ampule. So one ampule that contains 25 milliliters. And when I take zero point 0.5 ampules cross out, zero point 0.5 times 25 gives me 12.5 milliliters. Just coming back here, I would cancel out these units as well when we're solving these things, and I took care of that. One of the benefits of doing dimensional analysis is if you ever get stuck, you can at least see that you're crossing things out and you're left with what you're looking for when you're looking for a particular answer. So if I'm looking for ml, right, you could see that we are look or we're finding what we're looking for. When I'm looking for milligrams, we could see what we're looking for. Okay. So it just gives you a way to organize it. If you don't do it that way, that's okay. There's more than one right way. Number four, the nurse is calculating output for the patient with a continuous bladder irrigation. The irrigation infused throughout the shift at 200 milliliters per hour. Output for the 8-hour shift totals 2,350 milliliters. What is the true urine output for this patient in milliliters? So that's interesting. Um, this is a question that I'm unfamiliar with, but I'm going to give you my best guess estimate. So it says that they're getting this continuous bladder irrigation. So it sounds to me like they're flushing out the bladder at 200 milliliters per hour. And so what I would probably want to figure out is how much that is liquid wise. So 200 milliliters per hour over 8 hours is going to equal 1,600 milliliters. And then you can see the output is 2,350. So what I'm assuming, and you want to double check with your instructor, is that I would just subtract the 1,600 from the 2,350 mLs to get that see what the patient actually voided. So 2,350 minus 1,600. And then it looks like the answer should be 750 milliliters. I haven't seen a question like this, so this is my best guess as without knowing the key um, of what they're asking you to do, which is to calculate how much the patient voided in 8 hours, including the fact that they were being irrigated. Patient is to start on a heparin drip at 18 units per kilogram per hour. The patient weighs 165 pounds. The pharmacy dispenses heparin in 25,000 units, 250 ml, zero point 0.9 normal saline. The infusion pump should deliver how many milliliters per hour? And then I think this is supposed to say ml per hour here. So we'll just add that in here just in case it's missing. All right. So this question is a big one. There's a lot of steps in this. But basically, anytime you see something that has kilograms in it, that's kind of where I always like to start. And then I look to see is the patient's weight already in kilograms? It is not. So we have to also convert the patient's weight from pounds to kilograms. So how I'm going to do this problem is I'm going to start off with the patient that's 165 pounds. I'm going to convert pounds to kilograms. And you need to know that 1 kilogram is equal to 2.2 pounds. So you're dividing by 2.2. Now, you could put this into your calculator and set equal, but I would say if you need to round, save the rounding to the very end. So if you put this into your calculator, like if I take the 165 divided by 2.2, I actually get an even 75 kilograms. So we can actually go ahead and solve that and then leave it as is, and then that helps things. But if you get a decimal answer with with a question like this, don't do the rounding. Don't clear your calculator until the very end. Do the rounding at the very end. But since this is already at 75, we could just put that there. Then I'm going to multiply that 75 kilograms by the 18 units per kilogram per hour. And what that does is it eliminates kilograms, and now we're left with units per hour. So just because I have like a little bit of not much space here, the next thing I'm going to do is because I'm looking for ml per hour, what I want to do is find if I can convert units to ml. And I can because I have an IV solution of 25,000 units, 250 ml. So I'm going to put the 250 here. I'm going to put the 25,000 here. And then with my calculator, I'm going to take 75 times 18 times 250, which is going to give me a big number, 337,500. And then I'm going to divide that by the 25,000 units. Now, I will say, be careful when you're putting in numbers like 25,000. A common mistake is you put too many or too few zeros. So double check. Sometimes it's helpful to run it through your calculator twice just to make sure you're getting the same answer. But after I do all this, and after I've canceled out everything, and I know that I'm getting what I'm looking for, which is ml per hour, I get an answer of 13.5 ml per hour. Question 5 is actually called a standard weight-based heparin protocol. So you might see this a couple times, depending on how many times you have to take this particular uh, math dosage test. All right. Number 6, the patient with a hemoglobin of 6.2 milligrams per deciliter is ordered to have 1 unit of packed red blood cells to be transfused over 3 hours via an infusion pump. The blood supplied contains 315 mLs. How should the nurse set the pump? So notice that when we talk about infusions, we're looking for a rate. And the two pieces of information I need to know for rate is volume and time. And for this one specifically, I need to know ml and hour. So where's my mLs? That's 315. And where's my hours? That's 3. So to solve this problem, I'm just going to take 315 ml over 3 hours. And that's going to give me 105 ml per hour. If you initially looked at this and we were trying to and struggling and trying to figure out what do I do with this 6.2, 6.2 milligrams per deciliter is just telling you that that is what the patient's hemoglobin level is, which based off of the order would suggest that it's low. And so they're going to do this infusion and then probably reassess the patient's hemoglobin level, and hopefully that number goes up after whatever the standard time frame is for them to after receiving those RBCs. Okay, I'm going to clear the writing and then continue on with the remaining questions. All right. So we're on. See if I can pull up all of these. Yes, good. See if I can. Perfect. Okay. So for number 7, it says magnesium sulfate 20 grams per 500 ml is ordered to be administered at 1 gram per hour. At what rate should the nurse set the pump to? Again, milliliters per hour. So this one we do need to account for the fact that we have grams and mLs here. We can't just say 500 mil per hour. We need to do some converting. We need to get rid of the gram because the gram is included in both these things. So what do I mean by that? So first of all, when I'm setting up a problem like this, I usually like to stick with the rate and to make sure that my hour stays in the bottom. So when I write this out, I'm actually going to start with the 1 gram per hour. And then I'm going to convert the gram per hour to milliliters per hour. And a little trick here is pay attention to what number goes with the unit. So you notice that I'm writing it differently than how it's given to us, 20 grams for 500 ml, but I'm still going to put the 20 with the grams and the 500 with the ml. And when we're using dimensional analysis, we haven't changed this relationship. It's still 500 milliliters that contains 20 grams or 20 grams within 500 milliliters. We're saying the same thing, but we can flip these units So that way we can be left with what we're looking for, which is the or which is milliliters per hour. So now I'm just going to take 500 divided by 20, and we're going to get 25 milliliters per hour. If you ever find that you're like not knowing what to do with these numbers, or you're like kind of putting them wherever, write it out. Write out your units first. That's what I try and model. Before I put any numbers, I always try and put the units first. Okay. And then that way I know, okay, the 20 goes with the G and the 500 goes with the ML, no matter which way we kind of organize this. Okay. All right, says we have a patient weighing 103 pounds. They're to receive enoxaparin, Lovenox, 1.5 milligrams per kilogram subcutaneously daily. How many milligrams will be administered daily? And then round your answer to the nearest whole number. So, again, we have a patient that weighs 103 pounds. And we see that kilograms coming back into the conversation. So step one is we have to convert the patient's weight in pounds to kilograms. This is a good example of a time where you're going to get, if when I take 103 divided by 2.2, I'm going to get 46.8181818181. And what you want to make sure you do is keep that in your calculator. So like if I'm writing this out, I'm saying 103 divided by 2.2, and then I'm going to multiply by that 1.5 per kilogram. 102 divided by 2.2 is how we go from pounds to kilograms. So this all works out in the end, but I'll show you in just a second. So what I'm going to do is I'll take that 103 times 1.5 and then divide by 2.2, and that'll give me an answer of 70.2, and it tells me to round to the nearest whole number. So what they're looking for is 70 milligrams. Now, if you took that 103.2, or I'm sorry, 103 divided by 2.2, and you rounded that to 47, and you multiplied by 1.5, you would actually get 70.5. And then if you were to round to the nearest whole number, you'd actually be rounding to 71, which would make that your answer incorrect. So when you're setting this up, if you feel more comfortable just doing 103 divided by 2.2, hit equal in your calculator, leave it in your calculator, and then multiply by the 1.5. If you need a placeholder to be like, okay, but I need to know that it's the 46.8181 kilograms times the 1.5 milligrams per kilogram, that's perfectly fine, but don't clear it out of your calculator. Okay. Because what can happen, like I said, is, or the rule is you should be rounding at the end of your calculations, which includes your conversion of pounds to kilograms. Okay. So just double check that. You could even see you can put in 47 times 1.5 versus even just typing in 46.8181 times 1.5. And you can see that you could get two different answers when you're rounding to the nearest whole number. So the rounding can impact your final answer. Just pay attention to that, please. Number nine, physician orders vancomycin 1 gram and 250 milliliters normal saline to be infused over 90 minutes. At what rate should the nurse set the infusion pump to, round it to the nearest whole number? So here's a couple things. In the previous question, like number seven, we did include in our calculations the gram. But in this one, we're actually not going to include it. And the reason being is in question seven, it told us a rate of 1 gram per hour and then 20 grams per mil. So we needed to figure out how many milliliters per hour that was infusing at. Here, we just know that we have a medication, vancomycin, 1 gram of it, and it's in 250 milliliters normal saline, and it's infusing over 90 minutes. I just need to know the mLs and the time. Okay. So what I'm going to do is I'm going to write this. I'm going to actually show you two ways to set this problem up. I'm going to take the 250 milliliters over 90 minutes. Then I'm going to convert minutes to hours. That's one way. The other way, which actually is going to equal the same thing, is I'm going to take 250 milliliters and I'm just going to divide by 1.5 hour because 90 minutes is 1.5 hours. No matter which way I do it, I'm actually going to get to the same answer. Okay. So I'm going to take 250 times 60 divided by 90, and I'm going to get 166.6 repeating. So 166 point, and then a bunch of sixes here. If I take 250 divided by 1.5, I'm going to get the same answer, repeating. And so both of those, we're just going to round up to 167 milliliters per hour because it tells us to round to the nearest whole number. Okay. If it told us to round to the nearest tenth, then we would round it to the nearest tenth. All right. Question 10. The nurse notices that the infusion pump delivering heparin, 25,000 units, 250 ml, dextrose, 5% water, is set at 11 mil per hour. How many units of heparin is the patient receiving per hour? So this is a question asking you to convert ml per hour, the current rate, to units per hour. So what we're going to do is we're going to take as I mentioned before, I like to start with the rate. So the rate is actually 11 milliliters per hour. And then all we're going to do is convert milliliters to units using the available, which is the 25,000 units and the 250 ml. So I'm getting rid of ml and I'm converting it to units. So 250 ml down here, 25,000 units up here. So I'm going to take 11 times 25, 1, 2, 3 zeros, and I get 275,000 divided by 250, and I'm going to get 1,100 ml, or units, sorry, units per hour. So sometimes they want you to include a comma. I don't know that, but well, they do it here, so let's just throw it in there. So 1,100 or 1,100 units per hour. So again, we're just converting rates. Number 11, patient has received potassium chloride, 20 milliequivalent elixir. The medication is supplied by the pharmacy as potassium chloride, 40 milliequivalents per 10 ml. How many mLs will the patient receive? So the thing that a lot of students get hung up on is this milliequivalent. Okay. That's just the strength of the medication. You have grams, milligrams, micrograms, milliliters, units, and then sometimes you have these things called milliequivalents. So I'm going to treat it the same. I'm going to take my order, which is the 20 milliequivalents, over my available, which is 40 milliequivalents. And I'm going to multiply by my quantity of 10 ml. So 20 times 10 is 200 divided by 40, and we get 5 ml. 5 ml. All right, number 12. Patient is prescribed to receive potassium chloride, 40 milliequivalents. Sounds familiar. In 100 milliliters over 4 hours. How many milliliters should we set the infusion pump to? And then this this should say ml per hour. So here's the thing. They're giving us the strength, 400 milliequivalents in 100 milliliters, but it's also telling us over 4 hours. Okay. So what do I need when I have an infusion pump question? I need the volume and I need the time. So I don't need to worry about how much potassium chloride is in the IV. I just need to know that I have it available, the quantity, 100 milliliters over the time, 4 hours. And so we get 25 mil per hour. Number 13, the physician orders a basal rate of diluted 1 milligram per hour to be infused via PCA pump. The concentration of the diluted is zero point 0.2 milligrams per mil. How many milliliters will the patient receive every 4 hours? So I'm gonna this question could be answered just like how many milliliters like in that moment versus and then repeated every 4 hours, or how many milliliters are they receiving over 4 hours. So I'm gonna kind of walk you through both those answers. So again, I'm gonna start off with my uh my current rate, which is the 1 milligram per hour. And I'm going to get rid of the milligrams and convert it to milliliters. And then I'm going to use that by using my available. So I'm going to put my 0.2 milligrams down here, 1 milliliter here. And then when I do that, I think it's 5 again as well, but 1 divided by 0.2 is 5. Yeah. So I get 5 milliliters per hour. Now, what I don't know is, are they receiving 5 milliliters per hour? Are they receiving 5 milliliters every 4 hours? That's where this question's a little bit confusing to me. But given the fact that they also tell us that we have 5 milliliters per hour and that we have 4 hours here, what I can do is I'm just gonna make a little switch here. I'll just say 5 milliliters per hour, and I will go ahead and multiply by the 4 hours. And I do believe the answer they're looking for here is 20 milliliters. They want to know that that the patient's going to receive 20 milliliters of this in 4 hours because they're getting 5 milliliters per hour. All right, the last question here is patient is scheduled to receive piperacillin 3.37 grams per 50 ml, normal saline, IV to infuse over 4 hours. At what rate should we set the infusion pump to? So again, we're looking for milliliters per hour. So I want to just pay attention. Do I have milliliters? Yes. Do I have a time? Yes. Do I have another rate listed here? No. Do I have a strength? Yes. But the strength doesn't tell me what the rate is. So I'm just going to take 50 ml for 4 hours, which will give me 12.5, I believe. 50 divided by 4 is 12.5 milliliters per hour. And that's how you would solve these 14 problems. I hope you find it helpful. And if you have any other questions, please let me know.